Hello everyone, welcome to Pune University. My name is Dr. Manish Singh. I'm an associate professor in mechanical engineering department, and this is video lecture series on basics of mechanical engineering, and this is lecture number 1 of unit 1. So today's topic is introduction of manufacturing process. So let's see first content. So this is the detailed content which I'm going to deliver in this lecture. That is lecture level outcome, manufacturing process, their definitions, their classification, then metal casting and metal casting definition, then steps involved in the metal casting process, then detailed flow chart through which we can make a metal casting, and after this advantage and limitations, and after completion of this we will see the some multiple choice questions. So let's see, this is the lecture outcome. So after watching this lecture, student can able to learn how to define manufacturing process, and how to explain metal casting process, which is and what is the role of manufacture metal casting process in manufacturing. Is it right? And describe the key steps involved in the metal casting process. Means what are the steps involved for manufacturing a component with the help of metal casting process. And after that they also able to analyze what are the advantages of metal casting process, what are the limitations of metal casting process, and what are the component that can be produced with the help of metal casting process, that is application of metal casting process. Next, as far as the definition of manufacturing process, if I say, then manufacturing process is a nothing but it can be defined as a group of activities which is used to perform on a raw material. This is a raw material, and actually this is a lump of material which has low value, low value and low utility. Is it right? Low utility, low value and low utility. So we have a raw material which has low value and low utility, means this material directly cannot be used for any engineering application. Then we need to perform several activities through which we can convert this raw material into some useful form. Is it right? So this group of activities which we need to perform on this raw material to convert into high utility material is called as manufacturing process. So you can see here, this is a final product. This is a final product. This is a final product which has high value and high cost and high utility. Correct? So simply if I say the manufacturing is nothing but it is a group of activities, and group of activities means it may be a metal casting process, it may be a metal forming process, or it may be a metal cutting process, or it may be a fabrication process. Is it right? Fabrication process. Out of this, either metal casting is performed to convert this raw material into finished goods, or a group of activities are required to convert this raw material, low utility material, low value material into a finished product which is having high value and high utility. Is that right? So simply you can see here from the definition, it is a value addition process which converts raw material which of low utility and low value into, and now even this raw material is also having inadequate material properties and poor or irregular surface and size. Is it right? And surface finish. So these are the characteristics of raw material which converted into high utility and high value product with a definite dimension, form and finish. Is it right? Which can be having a functionality that can be used for any particular application. So this is called as a manufacturing process. So you can say this is a ore or a lump of material, and this is a bolt, nut and bolt. Is it right? Which can be used for fast training purpose. Is that right? Next, classification of manufacturing process. Basically, manufacturing process are divided into four broad categories. Is it right? Four broad categories. One is metal casting process. Another one is metal forming process. Then metal cutting process, and then fabrication process. Metal casting. Then metal forming. Then metal cutting. It is also called as machining process. Is it right? Metal cutting or machining process. And at the last, that is fabrication process. Basically, if I talk about metal cutting process, then obviously metal cutting is a process in which the desired shape is converting or obtaining by pouring molten metal into predefined cavity. Is it right? So this process involves from liquid state to solid state. It is right. Means we have raw material. We need to convert raw material into whatever solid material we have. First we need to melt it to convert liquid metal, and after that, once you get the liquid metal, then this liquid metal is poured into predefined cavity and again solidified it so that we can get a final product in the solid form. Correct? So this is a liquid to solid state process. And since in this we use liquid metal, therefore it can be uh, able to produce very complex object. Is it right? As we know that liquid can occupy any shape and size where we pour it. Okay. So that's why this is a very versatile process and which can able to produce a very complex object. Next one is a metal forming process. In this, the material, solid material, let's suppose if you have this is a solid material with a particular height and width and volume. So this is solid state, and it will be converted into another solid form, but its shape and size is different. You can see here. Correct? This is again a solid form, but its shape and size is different. Correct? So this is called as a metal forming process. Is it right? So basically in metal forming process, what we need to do, we need to reshape the solid material. Is it right? By plastic deformation of the metal. Here plastic deformation takes place. Here solidification takes place. Is it right? This is the difference. And both these processes are called as primary manufacturing process. These are called as primary manufacturing process. Is it right? Both are called as primary manufacturing. Why it is called as primary manufacturing? Because whenever we have actually in a earth we have a raw material in the form of ore. Is it right? Ore means this is the impurest form of material which has a mud, which has a several unwanted ingredients which are not acceptable for engineering application. Is it right? So this ore is further needs to convert into a metal, pure metal or alloys. Is it right? Pure metal or alloys. So when first we obtain ore from the earth, is it right? And which is impurest form of the material, and now it is heated in the furnace and purified in the furnace, and after that we will get a pure metal or alloys. Then obviously after heating, when you get this pure metal or alloys, then obviously it is present in liquid state, and we cannot store material in the liquid state, so we need to solidify it. So obviously, if you solidify without giving any shape and size in a lump shape, then its transportation is very difficult, because metal is obtained somewhere and it can be utilized in some other industries and other locations. Is it right? So proper appropriate shape and size is mandatory. So for conversion of this appropriate shape and size, metal casting and metal forming both involved. Is it right? Obviously, if you say, since in this the pure metal or alloys are available in liquid state, then obviously solidification is required. So in that case, a casting is involved, and through this casting we can make a ingot. A first shape of the material, that is ingot, whose size is very big size, around the size of the room. Is it right? And this is a square or a rectangular in shape. Is it right? And after that, obviously this its size is very big, so initially it can be deformed into some other form of shapes, like we can convert this into blooms, or we can convert billet, or we can convert a slab. Is it right? So these are the standard shapes that can be initially converted from ingot to these shapes. Okay. So this conversion is only possible by metal forming process. Is that right? So after this we will get a particular shapes. Actually this blooms is nothing but it is a rectangular in shape, with area cross section more than 200 centimeter square, and the length is around 8 feet. Okay. And similarly billets is having similar kind of shapes. Is it right? So these shapes can be easily transported from one location to another location. So this is called as metal forming. So without performing metal casting and metal forming, you never get a appropriate shape which can be used for any engineering application. And even I can say blooms, billets and slab is also a raw material for a particular process or for a particular application. Is it right? So these two processes are mandatory to perform. That's why this is called as primary manufacturing process. And now metal cutting, you can see here, suppose you have a lump of material like this, and you need to make a bolt like this. Okay. So how we convert this bolt with the help of this? Then simply you need to remove this extra material. You need to remove this extra material from this lump of material, and obviously it can be performed by metal cutting. Then this is called as a metal cutting process. So simply if I say it's a definition, then metal cutting is a process in which the desired shape and size can be obtained by removing extra material in the form of chip. Is that right? So this is called as metal cutting. And obviously this is a secondary manufacturing process, and where you perform this, obviously you have a particular sheet, you have a plate, you have a slab, you have a billet, anything. Is it right? So from this you just cut the extra material, and let's suppose for example, if you need to make a shaft, then you have a cylindrical rod. First we make a cylindrical rod. Is it right? With the help of casting and forming process, this is a cylindrical rod. And suppose if you need to make a shaft like this is a step shaft, then obviously by metal cutting, by turning process we can make this. Okay. By turning operation we can make this object. So this is called as a metal cutting process. So now you can see what is metal cutting process. And next, fabrication process. So what is fabrication? Fabrication process means joining of two or more pieces. Fabrication means joining process. Is it right? Fabrication is a joining process. Is it right? In which two or more pieces joined, either temporary or permanent. Is it right? Either we can join temporary, or we can join permanent, or even we can join a semi-permanent type. So this is called as a fabrication process. So simply fabrication means joining of two or more pieces. Is it right? So this is the detailed classification of manufacturing process. And out of this manufacturing process, we have several modern, we can say smart manufacturing process. Like we have additive manufacturing process, we have a laser cutting process, we have unconventional cutting process, we have unconventional welding process. Is it right? So nowadays we have several modern manufacturing processes we have, but yes, the whole word is mainly depends upon these four basic manufacturing process which are very old. Is it right? And these processes were used since 3000 to 4000 year back. Okay, so now you can see still we use these processes, and obviously recent processes are more advanced than the previous one. Is it right? So advancement takes place, the basic fundamental or basic principle is remains same. Is it right? That's why we study these processes. Next, out of this, the first category of the manufacturing process is metal casting process. So what is metal casting process? So you can see the definition. Metal casting is a process in which molten metal is poured into predefined mold cavity. Is it right? Molten metal is poured, allowed to pour into a predefined mold cavity, and after that we just solidify it. Correct. So basically in this we have a mold making activity, we have pouring activity, we have solidification activity. So several activities are performed, and after solidification we get, obviously we get a product which is also known named as casting product. Is it right? This is a final product or final goods. Is it right? And this is also called as a casting, and the entire process which involves for producing casting is called as metal casting process. Is it right? So simply you can say here how we make a product with help of metal casting process. So initially first we need to make a mold cavity like this. Here I am representing 2D figure. So you just see here how a basic element and basic steps in metal casting, especially sand casting process. So you can see here this is a pouring basin, this is a sprue, and after that we have a runner. This is a runner, and this is a mold cavity. The mold cavity, and it is not necessary to make mold cavity in one half. I will tell you in a details in the later on lectures. And like this. So this is a outline of the metal casting process. So you can say this is a pouring basin, and obviously around this we have a sand like this sand, molding sand actually. And in this molding sand we just make a cavity. Is it right? In this molding sand we just make a cavity. This is called as a mold cavity. Mold cavity. And obviously this entire setup is made up of two halves. Is it right? So this upper part is called as hoop, and bottom part is called as drag. Is it right? And now you can see the step by step process. So this is a pouring basin, and after that we have a sprue. This is a runner, and this is a riser, and you already know this is a mold cavity. So how we perform this metal casting process? So basically we have a ladle. Is it right? We have a ladle like this, and through this ladle first we transport the liquid metal from the furnace. Is it right? A furnace we have in the foundry which melts the metal, and after that with the help of this ladle. Actually this is called as a ladle. Okay, so with the help of this ladle we just transport the metal and pour the molten metal into a this mold cavity. So obviously initially it fills the pouring cup, and after that this molten metal starts moving towards sprue, and from sprue it moves towards the runner. Yes or no? And after the runner, initially it fills the mold cavity, and once the mold cavity is completely filled, then this molten metal starts moving towards the riser. And if this molten metal is coming out from the riser, then we can say our mold cavity is now filled, so stop pouring. Is it right? So like this you just start pouring from here, and the molten metal exit from here, and if it exit from the here, then we ensures the our mold cavity is filled. Is it right? So this filling process is called as a casting process. And after that, obviously, this is a liquid metal. So now we just allow for some time so that this liquid metal gets solidified. And once it gets solidified, then obviously we get a solid piece of metal like this. We get a solid piece of metal like this, because a molten metal which is placed everywhere, is it right? In the runner, in the riser, in the pouring cup, everywhere we have a molten metal, and the entire molten metal gets solidified. So everywhere we get a solid metal, and once you get the solidified it, then you just break this molding sand. You just break this molding sand and remove this pattern from, sorry, this solidified part from the molding sand. Is it right? By breaking it, means this mold cavity or entire system is not reusable. Is it right? It is only used for making a one component. And after solidification you just break this, and after breaking obviously we get this product. So by the metal cutting process you just remove this extra metal from this, then you will get a final product like this. And obviously we will perform after some a finishing operation, like we just do the short blasting so that we can get appropriate surface finish. And then obviously some, if it is required to do machining, then we can do the machining process. And then obviously we do the some other finishing processes. Is it right? So this product is actually called as a casting product, or you can say this is a final product. Is it right? And this entire process through which you make this casting product is called as a metal casting process. Is that right? Okay, next, what are the steps involved in the metal casting process? Then obviously first we need to make a pattern or a core. This is a primary steps, pattern making. So let's suppose if you want to make a casting like this is a object which you need to produce. Is it right? So initially first we need to make a, and obviously let's suppose if it has a hollow cavity, true hollow cavity. Is it right? This is our product. Okay, this is our product which I need to produce with the help of casting process. Okay, so as the product required, similar kind of pattern will also need to make. Okay, so first step is to make a pattern. Then obviously the size of the pattern is not exactly equal to the size of the product. Why? Because in this, since the process involved melting and solidification of the metal, therefore due to melting and solidification its volume changes, and since its volume changes, therefore some dimension may also alter. So to accommodate this change dimension, we just make slightly bigger than. Okay, if this is a product which is size of 100 mm by 50 by 100 mm, then the size of the product is slightly larger than the this size. Is it right? Means this is 100 plus delta L. Is it right? Similarly this is 50 plus delta, let's say if this is a width, so this is delta B. And similarly this is height, so this is 100 plus delta H. Okay, so we make this pattern slightly bigger than the actual product. Is it right? So this is pattern. And pattern is simply, if I say it's a definition, then you can say pattern is a replica of an object which is to be cast. Is that right? So this is called as pattern. And since you can see in this we have a hollow cavity, so for this we also need to make a core. Is it right? And its size is also not exactly equal to the size of the hole which required. This is also this generally it is made slightly smaller than the size of the hole. Is it right? Its a diameter is slightly smaller than the hole size, and obviously length is same as the product size of the length required. Is it right? So this is called as a core. Is it right? So first step is to make a pattern or a core, and next a second step, that is molding sand preparation. Is it right? Then obviously in the previous slide I have told you this is a molding sand which is filled inside the outside this getting a system. Is it right? So first we need to make a molding sand, and you can say what type of actually preparation required in the sand. Why it is called molding sand preparation is the essential step. Then obviously in the molding sand we have a silica sand, we have a silica sand along with we add some clay. Okay, because sand does not have any binding property. Along with this clay we also add some additives. Additives and obviously we also add some water. Is it right? Because without water, or instead of writing additive, simply we can say some binding agent. Okay, the binding agent plus water. Okay, so obviously when you mix these ingredients, then obviously the mixing of these ingredients is very essential, and these ingredients should be mixed in a particular proportion which has a very good strength, hardness, ductility like this. Is it right? So for getting particular appropriate molding sand properties, we need to mix these ingredients in a particular ratio, and obviously after mixing we need to perform several tests so that we ensure our property is good or not enough. Is it right? Because there is no sure way to mix a particular material or ingredient in a particular ratio. We don't have any particular mathematical relation for determining this. So this is a experimentally we can identify, and obviously this is error and trial based method. Okay, and next, mold cavity preparation. Once the pattern is ready, the sand is ready, now we just make a mold cavity. Is it right? How we make a mold cavity? Let's suppose this is a mold box. This is a mold box. Is it right? uh, This is a mold box, and it is either made up of wood or it is a made up of a metal. Is it right? Both materials can be used. And its a bottom and top surface is open. So simply, this is a three-dimensional shape, and now I am drawing 2D. So this is a mold box which is placed on the this is a flat surface which is also called as surface plate. Is it right? This is a surface plate, and this is a mold box which is looking like this. Okay, and after that we just put a pattern. So you can see this is a pattern. This is pattern. Okay, and after placing this pattern we just pour the molding sand which already we prepared. Okay, like this. Okay, and once we pour this molding sand, then with the help of a ramming tool, we have a tool like this. This is a ramming tool. So with the help of this ramming tool, you just ram it. Okay, sand को ram करना है. And after that, after this ramming, when you get appropriate bonding property in the molding sand, you just remove all the excess sand with the help of some tool. Is it right? Then exactly flat surface we get at the top surface also. Okay, and after ramming, you just invert this pattern by 180 degree, sorry, this system by 180 degree. So in that case now you have a pattern like this. Here we have molding sand. Then of course we have a pattern somewhere here, and here we have molding sand like this. Everywhere we have molding sand, and this is a surface. Okay, surface plate. Only this mold box is inverted. Okay, and after inverting this, the pattern is now placed at the top of the system. Yes or no? And after just doing some small shaking, we just remove it. Okay, and once you remove it, then you will get a cavity like this. Is it right? After removing this pattern, you will get a cavity like this. Is it right? So this cavity making process is called as mold cavity preparation. So this is one half, and similarly we can make a second half also, and both halves may assemble to each other. Then you will get a system like this. Is it right? And obviously along with this mold cavity, we also make a passage through which we can pour the molten metal, like a pouring basin, like a sprue, like this. Okay, and next step is melting and pouring. Obviously we just melt the metal and pour the metal. Yes or no? And how we melt? Obviously this metal is melted into a, we can say, furnace. And after melting, when the complete liquid metal is available, now it is poured into the mold cavity. And then obviously after that, you just allow it for the solidification. And after solidification, you need to perform uh, removing all the extra part, and obviously do this finishing process. Okay, so this is a detailed sand casting process. This is also called as a sand casting process, which I explained earlier. And if I arrange all these processes in a sequential manner, then you can see this is a pattern making and core making. Is it right? Both process and sand preparation. Is it right? So these processes may perform parallelly. Is it right? Correct. And after that, once the pattern, core and sand is ready, we just make a mold cavity. And once the mold cavity is ready, now we melt the molten metal and then pour this molten metal into a mold cavity. And once it get poured properly, then allow solidification, then removal of the sand, then cleaning, then finishing, which I already told you. So just I'm representing all the process in a sequential manner in a flow chart. Okay, next, what are the advantages of metal casting process? Then obviously metal casting process have several advantages. Like the metal casting process involves pouring of liquid metal, so it can able to produce a very intricate or very complex object externally and internally. Is it right? Which is not possible by some other processes. Is it right? Correct. Similarly, sometimes due to metallurgical constraint of some material, it can only be cast. Because see, let's suppose if we have some material which like a bar, a rod, a plates, correct, and some materials which has a metallurgical constraints which cannot be made, like a very hard material cannot be formed, very hard material cannot be cut. Is it right? Like this. So how we convert this hard material into useful part? Then obviously it can melt properly and then cast it. Is it right? So like this. So because of some metallurgical constraints, since some metal cannot be saved properly by the other manufacturing process, then casting is one of the process which can able to do this. Is that right? Next, it can be used for making a very small, like from few hundred grams to very large casting up to 100 tons product can be easily produced. And this is also one of the biggest advantage of metal casting process. Is it right? And it is economical process because its tools are very cheap in cost, and wastage of material is also very less, because whatever extra material we get is it can is again cleaned properly and remelt again and reused again. Okay, so since the wastage of material is very less, or you can say the tooling cost is very less, therefore this entire process is a economical process. Okay, then apart from these advantages, obviously here we have some disadvantages, like uh, sometimes of during casting the crack may propagate, is it right? So suitable designing parameter, suitable melting parameter or designing parameter of the mold cavity is very essential, so that we can produce a crack free casting. Next, limited to small quantities, casting is a slow process, it is a time taking process, is it right? Because several activities are involved, is it right? So therefore uh, casting is able to produce a small number of quantity, is it right? So it is suitable for small quantity, when it, especially when it done by the manual process. But nowadays we develop several automatic casting process and permanent casting process, is it right, which are able to produce a component in a very rapid speed, is it right? So obviously for the sand casting it is a limitation, but while for unconventional, or you can say um, uh, permanent mold casting process, this limitation can be avoided. Okay, surface finish of the product is also low quality, and obviously after that machining is required, is it right? Why? Because see, we have a sand mold cavity, is it right? And according to the sand size the surface we will obtain, correct? So obviously the surface finish of the casting produced by the sand casting is not as good as the required for the any particular application. Therefore, further machining process involves. Is it right? And similarly, dimension accuracy is also not good. So, for further finishing is required. Obviously, by the machining process or by the finishing process, we can obtain the appropriate surface finish as well as dimensional accuracy. And one of the biggest limitation is a large number of labor required. Is it right? Because most of the sand casting process are manual process, therefore large number of labors required. And another biggest limitation is a casting process is a polluted process. Huge amount of pollution produced, is it right? Because mostly coal based fuel is used for melting the molten metal, therefore it will produce such a very toxic fume, is it right? So pollution is also one of the major concern with reference to the sand casting process. Next, these are the some application like machine tool can be made with the help of casting process, like machining, casting, plastic molding, forging, extrusion, forming. These tools can be made. Okay, plant machineries like chemical, petroleum, paper, sugar, textile, steel, and thermal power plant. Many machineries are there. Like in a power plant, we have turbine, compressor, pump. Is it right? Similarly, in chemical industry, we have several compressor pumps like this. Petroleum industry and other industries, so plant machineries can be made by the casting process. Heavy equipments like construction, farming, and mining. Similarly, you have seen construction of building. Then a very huge size overhead crane is used, and its base is entire base is made by the casting process. Is that right? And for the transportation purpose, you can see automobile engine is produced by casting, aerospace, railway, shippings. These are the sectors where we many components are produced by the casting process. Is that right? Okay, so after detailed discussion, we analyze what is metal casting process, how to make a component with the help of metal casting process. Is it right? And what are the detailed steps involved in the metal casting process? And after that, obviously, we see the advantage and limitation of the metal casting process. So after the completion of this lecture, students are able to understand the basic introduction of metal casting process. Is it right? And let's see the some MCQ type question. What is the primary purpose of manufacturing process? Okay, so you just pause this video and try to give answer. Okay, so the right answer for this question is to create a final product from the raw material, to refine the raw material, produce the weight, to mix two metals. So the right answer is to create a final product from the raw material. Is it right? Next, what is the basic definitions of the metal casting process? The process of heating metal until it becomes liquid and pouring into mold to create a desired shape. So obviously this is option is a correct answer. So I'm not moving with the another options. Just read properly. Okay, next, which of the following is not a step involved the metal casting process? So you can see not. Okay, so melting the metal, no, this is wrong answer because melting is required. Pouring the metal into mold cavity, yes, this is also required, so this is not right answer. Removing the mold from the molten metal, mold from the molten metal, so yes, this is not a step of a metal casting process, that's why this is a right answer, because solidifying is also a step of the metal casting process. Okay, next, which of the following is a major advantage of the metal casting process? It can only be used for small scale production, complex shapes. It require very high temperature. It is limited only for few types of metals. So the biggest advantage of casting is a very complex shapes can be easily produced. Apart from this, all our options are the limitations of the metal casting. Okay. And next, which of the following is a limitation of limitation of the metal casting process? Limited to low volume production, high setup cost, inability to create complex shapes, require minimal energy input. So the right answer is here we need to identify limitation. Okay, so limited to low volume production, is it right? This is the right answer for this question. So this is all about this lecture. So hope you will enjoy this lecture. So thank you and we'll meet in the next lecture.